Hi everyone, in this video we'll be discussing the chemistry section of 1st February Shift 1 paper. The level of the questions was very simple. I would say the questions of chemistry section in 31st January were slightly tougher, but if we talk about the 1st February session, chemistry section was very easy. So let us see. The first question of inorganic chemistry is among the following homoleptic complexes. Homo means same. So homoleptic is that complex in which all the ligands are same. I can see in the first case all the ligands are same. It is not the case in the other three. So homoleptic complex is the first one. The color of NiH2O6 2 plus is green. Yeah, that is true. We have Ni plus 2. This we have studied in D and F block, that the color of Ni plus 2 is generally green. So if we talk about Ni plus 2, it is 3D8 and the ligand is weak field ligand. So it would be 1, 2, 3, 4, 5, 6, 7 and 8. I can see there are 2 unpaired electrons and due to which color can come, right? So it is green in color. Next, if I talk about NiCN4 2 minus, again we have Ni plus 2, we have 3D8 configuration, but we know Cn minus is a strong field ligand and we will get a square planar complex. So basically here the electronic configuration would be something like this, right? So 1, 2, 3, 4, 5, 6, 7, 8. All electrons are paired. It will be colorless. That is correct. Both the statements are correct. Very simple question from coordination compounds. Next, boiling point of NH3 is greater than pH3. Yes, that is correct. If we talk about NH3, there is hydrogen bonding. In pH3, there is no hydrogen bonding. The forces of attractions are very poor. So in pH3, H bonding is present, whereas NH3, only van der Waals force is present. This they have messed up, and actually the reverse is true. So first is correct and the second is incorrect. Select the correct order of ionic character of the given species. So if we talk about ionic character, or if we talk about an ionic bond, I would say that for an ionic bond, we need 2 elements, one electropositive, one electronegative. So one should be a very good metal, another should be a very good non-metal. Right? So out of the options, this may be our answer, and it is actually our answer. So lithium fluoride should have the highest ionic character, then K2O. It is also ionic in nature. The worst should be N2 because this is perfectly covalent. So this cannot be our answer. N2 and LiF is present in all three. Okay. K2O is better than ClF3 because ClF3 is perfectly covalent. I wouldn't say perfectly covalent, but it is having higher covalent character as compared to K2O. So K2O, right? So either it would be the first option or it would be the third option. So if we talk about sulfur and oxygen and chlorine and fluorine, the electronegative difference in chlorine and fluorine is higher. So the correct answer would be first. Right? Next, in case of isoelectronic species, F minus, Ne and Na plus. Okay, these are isoelectronic. If we talk about all three of them, the number of protons, which is atomic number, this is basically 9, this is 10 and 11. The number of electrons are 10, 10, 10. So in the first case, 9 protons are attracting 10 electrons. In this case, 10 protons are attracting 10 electrons. In this case, 11 protons are attracting 10 electrons. So in this case, the force of attraction would be higher. So everything depends upon the nuclear charge or the Z effective. Right? So the correct answer is 3. Next is, for an ionic reaction in organic compound, which type of bond cleavage occurs? So bond cleavage is basically For example, I can have either A plus and B minus, which is heterolytic, and this is homolytic. If we want ionic reactions, I want ions, if I want ions, the cleavage has to be heterolytic, right? Homolytic cleavage will not take place. Again, a very simple question. They are asking which are amphoteric in nature. So amphoteric are basically the oxides of Sn and Pb in all oxidation state, and generally +4 oxidation states of D block metals. So this is amphoteric, this is amphoteric, SiO2 is acidic, P2O5 is acidic, Al2O3 is amphoteric, right? CO2 is acidic, CO, NO, N2O. All these three are neutral. Right? SNO is again amphoteric. The correct answer would be 4. Very easy question again. See, they are just asking which of the following are trigonal bipyramidal. Basically, I need sp3d or dsp3 hybridization. So you know how to calculate hybridization. Just calculate the total number of valence electron divided by 8. If there is a remainder remaining, you divide that remainder by 2. So you know PCl5 is actually 5 bond pairs, 0 lone pairs. So this is sp3d, this is what we require. FeCO5 is again what we require, right? I hope you know the structure. It is something like this. BF3, this is trigonal planar. BRF5 is square pyramidal. Yeah, it is square pyramidal, so it won't be the answer. This is sp3 hybridized, and PF5 is same as PCl5, so it will also be your answer. The correct answer would be 3. And if you are wondering about this structure, let me tell you, it is something like this. Correct answer is 3. For A to B, lowest oxidation state of an element is -2. Find number of valence shell electron in B. So basically, if we talk about A to B, we have studied this in junior classes that crisscross rule is applied. So whatever is present here will go at the top of A, whatever is present here will go at the top of B. And generally we write, generally I am saying, we write cation first and an ion later on. So it is B2 minus, and they are saying that is the lowest oxidation state. So this is B2 minus and this is +1. And since it is accepting 2 electrons, it would have had 6 valence electrons already, right? That is why it is accepting 2 more, and on accepting 2 more it will have its complete octet, right? So the correct answer is 6 in this case. Next, let's move to physical chemistry. The first question is which of the following is correct for adiabatic free expansion? So we know if it is adiabatic, then Q has to be 0. And if it is free expansion, there is no external force. Whenever the external force is 0, the work done would be 0, because work done is always against the external force or external pressure. And if these two are 0, from the first law we know that delta U is Q plus W, that is also 0. So all the 3 values are 0. That is why it is said that free expansion is adiabatic and isothermal at the same time. Right? Why isothermal? Because delta U is 0, so delta T would be 0. Right? Next is a plot between de Broglie's hypothesis, de Broglie's wavelength, and the momentum, which is lambda is equal to h by p. So this looks like lambda into p is constant. That means xy is equals to constant, or a rectangular hyperbola, right? Lambda and p would be inversely proportional to each other. Among the following, which is redox disproportionation reaction? In disproportionation reaction, we have one oxidation state on the left, which is intermediate oxidation state, and on the right hand side we get 2 oxidation state, not second, I would say 2 oxidation state, one above, one below the intermediate oxidation state, obviously. So Cu plus going to Cu0 and Cu plus 2, yes, this is correct. I minus 1 plus 5 going to 0, this is actually reverse of disproportionation reaction. This is comproportionation reaction. Opposite of disproportionation reaction is comproportionation reaction. Here Mn is plus 7, it is going to plus 6 and plus 4. This is not a disproportionation reaction. The last reaction is just a redox reaction, it is ion exchange reaction. So disproportionation reaction is the first one. We are given with 3 NaCl samples and their Vent-Off factor, I1, I2, I3. The Vent-Off factor doesn't depend upon the concentration. It only depends upon the sample which we are taking and the solvent which we are taking. The solvent is the same in all the 3 cases. So the value of I would be the same. In all these 3 cases, it would be 1 plus alpha, considering that the degree of dissociation is 100%, so it will be approximately 2. Right? Vent-Off factor doesn't depend upon the concentration. Next reaction is a very simple reaction to be balanced. If we talk about Cr2O7 2 minus, we have H plus and electrons. We have 2 Cr plus 3, so chromium is balanced. Oxygen are 17. Oxygen are 7. So on the other side, I will require 7 water, and due to this, we'll have 14 H plus. So we'll have 14 H plus. I think everything is balanced except the charge. So if we talk about the charge, it is minus 2 plus 14. So it is plus 12, and on the right hand side, it is plus 6. So we need 6 more electrons so that we get down to plus 6. So the answer would be X is 14, X is 14, right? Y is 6, Y is 6. This is the correct answer, right? Very simple question. Next question is directly from ionic equilibrium. They are asking the pH of a salt, and if you see, this salt is of a weak acid and weak base. For a weak acid, weak base salt, the pH does not depend upon the concentration. So the formula for that is pH is equal to 7 plus half pKa minus pKb. By the way, if you see here, K and Kb are exactly same. That means pK is equal to pKb, or I can say this is 0. So the solution would be neutral. The pH of the final solution would be 7 itself. Next question is from mole concept. If you see here, PbCl2 are given as 72 millimoles and NH4 whole thrice PO4 is given as 50 millimoles. So the limiting reagent we calculate by the number of millimoles or moles divided by the stoichiometric coefficient. This is 24 and this is 24, this is 25. This is LR. This is limiting reagent. So from 3 moles of this, I get 1 mole of this. So from 72 moles of this, I would get 1/3 of that, right? So 1/3 means 24 moles itself. 24 moles of these are produced. On the other hand, if you ask about NH4Cl, although that is not asked, that would be 72 into 2, right? From 3 we are getting 6, so from whatever the number we have, we'll get the double of that. In next question, they are asking the E of cell. So basically we can use Nernst equation. E of cell is E naught of cell minus 0.059 by N. You can see N here is 2, and log of concentration of product, or I can say partial pressure of product divided by concentration of H plus square. This is 1. E naught of cell for an SHE, standard hydrogen electrode, is 0. So this is minus 0.059 by 2. Log of partial pressure is 2, so log 2 is 0.3. So approximately, if I see, this is minus 0.06 into 0.3 by 2. This is 0.03. So 0.009, I guess, right? Minus, so it is minus 9 into 10 to the power minus 3. The value of X is 9. Again, an easy question from electrochemistry. So let's see the questions of organic chemistry. They are asking what is the complementary strand of the DNA. This. So we know A always forms a bond with T, 2 hydrogen bonds, and G always forms bond with C, 3 hydrogen bonds. So A and T are complementary. So for A it would be T C G A G T. I think B is our answer. Second option is our answer. Next, aniline and aminobenzene both are same compound. Aniline and aminobenzene both are different compound. Only one of them can be correct. We know aniline is basically benzene and NH2, and this is also called as aminobenzene, just like chlorobenzene, right? This is called as chlorobenzene, this is called as aminobenzene. Both of them are same compound. Useless questions they are asking, no? Next we have toluene, and with toluene we are reacting with two equivalents of chlorine in the presence of light, or H nu. So basically we know in the presence of this we form a free radical. Whenever we have a peroxide H nu or very high temperature, we generally form a free radical. Since it is two equivalent, in free radical formation the free radical would be more stable at the benzylic position, right? And since we have to add two chlorines, so this will be our answer. And then NaOH will basically convert this to 2OH, and then water will be eliminated. As 2OH on a single carbon is not stable, we will get benzaldehyde, right? So it would be CHCl2 and benzaldehyde. First is our correct option. The order of reactivity of the given compounds towards electrophilic aromatic substitution. So basically they are talking about EAS. We already know. I think this question, there was a similar question in 31st January shift 2 paper as well. If our benzene ring has a electron donating group, it would be electron rich and it will easily attack on an electrophile. So what I need is, I need a better electron donating group, and I can say the better electron donating group is phenol, because it is giving the electron density through plus M. CH3 is giving through plus H. This is basically net minus I. I know there is plus M, but minus I is dominant. So best would be first, then second, then third, then fourth. I think it is in line 1, 2, 3, 4. NH2 is a strong activating group, correct. Aniline does not give Friedel-Crafts reaction, correct. What happens with NH2? You know NH2 is having lot of electron density, so it can activate the ring. And since it has high electron density, what it can also do is, if we have something like this, let us say we are trying to do an alkylation reaction, what will happen? Alkylation or acylation reaction. Let us say we have an acyl group, NH2 will attack and it will eliminate the chlorine. I will get an acylated product or acetylated product. This is not a Friedel-Crafts reaction. In Friedel-Crafts reaction, the addition of the electrophile takes place on the benzene ring. Here it is not taking place on the benzene ring. It is taking place on the nitrogen. So both statements are correct. Find out the total possible optical isomers of 2-chlorobutane. Useless question they are asking. If you see this is optical, this is chiral carbon, and if it is chiral compound, it has two possibilities, that it can be R or it could be S. There are two isomers, two optical isomers possible, one structural isomer possible. Now if they would have asked just the total number of structures, the answer would have been 1. The number of optical isomers are 2. The number of deactivating group. Deactivating group is one such group which has net either minus M or minus I or minus H. So we know CN has minus M. It is taking the electron density. Basically you can connect all these groups to a benzene ring. CN will withdraw the electron density because it is minus M. Nitrogen has lone pair, so it can donate, it will be plus M, although weakly activating, but it is activating. Again oxygen, it can donate weakly activating, but again activating. This is connected to carbon. And you may get confused between these two options. The first case is OCOCH3 and the second case is C double bond OCH3. In this case oxygen donates to the ring. In this case oxygen is withdrawing from the ring. Okay, so this is minus M group, this is deactivating group. Again nitrogen can donate, activating. OCH3 can donate, activating. So I think only the deactivating groups are these two. The correct answer would be 2. So that is all for this paper. This paper was very easy. So I think the paper of 1st January shift 2 would also be very easy. Let us see. We'll see it in the next session.